In this video, we're going to talk about congruence classes. Suppose we have two numbers, a and b. If a minus b is divisible by a number m, then we say a is congruent to b mod m. In other words, if m divides a minus b, then a is congruent, and we use this symbol here, a is congruent to b mod m. We refer to our number m as the modulus. Another way to describe the relationship between m divides a minus b and a is congruent to b mod m is to say that a and b have the same remainder when divided by the modulus, m. This creates an equivalence relation on the set of integers. In other words, it divides integers into a set of equivalence classes, also called congruence classes. Let's take a look at one congruence class. Let's consider the congruence classes which correspond to modulo 4. When creating our congruence classes, we are restricted to using 0, 1, 2, and 3. If we were working with modulo 6, we would use 0, 1, 2, 3, 4, and 5. If we were working with modulo 2, we would only use 0 and 1 to create our congruence classes. Since we're setting up congruence classes modulo 4, for each of our numbers 0, 1, 2, and 3, I'll write a subscript. For congruence class 0 mod 4, we'll look at the integers from negative to positive infinity. We know that 0 needs to be part of this congruence class. Our difference between each integer will be 4. So we have 0, 4, 8, 12, and so on. And in the negative side, negative 4, negative 8, etc., extending to negative and positive infinity. Let's look at congruence class 1, modulo 4. We know that 1 will be part of the congruence class. And then we'll simply extend in both directions by increments of 4. Looking at congruence class 2, modulo 4, we'd have 2, 6, 10, 14, 18, and so on, and extending in the negative direction, negative 2, negative 6, negative 10, and so on. For congruence class 3, modulo 4, we'll have 3, 7, 11. We would continue in increments of 4. Moving in the negative direction, we would have negative 1, negative 5, negative 9, and so on. As you can see, creating congruence classes for specific modulus is fairly straightforward. This concludes our example. I hope you found it helpful, and we'll see you next time.